Okay, my friends, so now we've got this fun data set of our distances from our geographic centers, our geographic midpoints of our 3 predicted towns that the New York Times quiz gave us, all the way to the hometown that y'all claimed. Now, there were some interesting things. Like I said in the video before, I've got a couple people that are from the West Coast, but the New York Times actually thought they were from the East Coast, or vice versa, which is extraordinarily interesting and might screw with the data a little bit. And I do want to chat about that. This Indiana one happened here too. It looks like we thought we were from Carson, Indiana. We're actually from Portland. So I'm going to look at the data here, and we're going to make a little histogram. I'm doing this because, yeah, that's what I kind of thought was going to happen. I had a gut feeling about this, and here's why. When you're measuring distances, there's always a smallest value, and that's 0. For example, if my geographic midpoint landed on my hometown, there'd be no distance between. I'd be off by nothing. But technically speaking, there are thousands of miles at the high end of the day, and you're actually seeing it over here, because if they pick the wrong coast, if it picks the wrong coast, then you're going to have, like I said, you know, if it thinks you're from North Carolina and you're actually from Seattle, well, then it gets interesting. And this often happens with folks that move around a lot. So this becomes a harder question to deal with. I'm going to goof around with this. I don't think there's going to be any way of making this not look skewed. Yeah, this is so heavy on the, I'm going to actually, and I'm not even going to bother calculating a skew value for this. Because it's too skewed. We've got too much on the low end and not enough on the right end. As a matter of fact, you see these 2 data points right here? We haven't really talked about this much in class, but this is a good time to talk about it right now. Whoops. Those 2 data points on the end there, would you stop moving that Excel? Here, to hell with you. I'll just make it taller. Those almost seem like they don't belong with this data set over here. I mean, if you think about it, they are so far away. They are double the distance away, if not more. It almost is like the algorithm malfunctioned for those 2 people, so we shouldn't include them in the data set, because let's just take a look real quick. Average. The average from the entire data set right now is 728 miles. The median of the same data set is going to be lower. Yeah, 517. So the average is like 1.5 times as big as the median because of those outliers. You know what? I hate doing this, generally speaking. But what I'm going to do is, dear friends, I'm going to delete those 2 large extreme values, the 2438 and the 2795. Not because I like deleting values. I don't like that at all. But because I think, well, actually, I think my gut feeling was actually correct. This is still skewed, but nowhere near as skewed as it was before. You know what? I said I wasn't going to calculate the skew, but I am. What was the skew? Was it close to 2 before? Yeah, man, it's super skewed. And that's just a measure of the difference of these 2 values up here. It's not an exact measure of the difference, but it's close. If I remove those 2 values, yep, the skew drops below 1, and all of a sudden it's within a range that we can tolerate. Okay, my dear friends, I want to revisit what I just did, because some of you might be thinking to yourself, how am I going to know when I should just delete data points from a data set? And the answer is so multifaceted and not at all simple. There's no hard and fast rule you can say, these data points don't belong so. There's some quantifiable things you can do. So check this out, for example. If I go back into the original data set like this, and instead of creating a histogram, create what's called a box and whisker plot. It's the same exact data. We made one of these in class together. When you look at the graph, these 2 points up here are the outliers. Now, how are they being measured as outliers? I wish this class had more time to get into this more with you, but it's using something called the interquartile range, the IQR method for identifying outliers. It's effectively very similar to standard deviations, But since the data is often skewed when you're pulling outliers from, you need something besides the mean and standard deviation to use. You should use something besides the mean and standard deviation. So you use what's called the interquartile range method. I encourage you to Google it if you're interested. Because of that, we can identify those two data points as outliers. Now, once we do that, we can also delete them from the data set, and look what happens. I'm going to take these two data points away, and even though we now have a smaller data set, we've got a more concise, consistent data set. So, again, not a huge fan of removing data points, but from a research perspective, it's too hard to believe that all of us sitting in that room are from a homogeneous population, right? Some of us have moved around a lot and some of us haven't. And I'm going to go with the hypothesis that I can't test right now, that those who end up on one coast but who the New York Times Mini thinks are from another coast are perhaps some of those people that move around quite a bit. Anyway, just want to take a small aside right now and explain to you why I felt somewhat justified in removing those two data points. All right, so now I think we can now trust a t-interval because the data's not so highly skewed that the sample average will be off. And if the sample average is off, the central limit theorem won't kick in because we've got too much skew. And we've got a really small data set, which is the other problem. All right, I'm happy. So we've got an average. I'm going to do a little work here. We've got an average. We now need a standard deviation and we need a sample size. So the standard deviation, just the div. From now it's pretty much, it's a pretty big standard deviation regardless, even though we cleaned up the data quite a bit. And we're going to count how many data points we've got. I think we've got like 20 left now, right? 22 left. Okay, beautiful. I'm going to take this. Let me open up my Excel calculator because that's the one we want to use for the t-interval. There it is, and it's actually, I opened it right up to where we needed to be. And we just need to take the average standard deviation and the sample size and drop it in. So I'm going to copy and paste it just to make my life easier. Copy it in as a value. There we go. All right. Which tells us that on average, this tool is getting us between about 390 miles and 724 miles from our actual hometown value. Now, is that good or bad? I'm not going to talk about that because this is one of those cases I mentioned in class yesterday. The examples we did in class yesterday talked about comparing a confidence interval to a value, right? This one, we don't have a value. I just kind of wanted to see, on average, how close does this tool get us to our hometown? And the answer is between about 400 miles and about 750 miles. Is that close? Well, I don't know. I mean, my home state of Delaware is pretty darn small. And actually, I couldn't help but notice my data point was the most precise one of all of us. This is me right here. I was the only person within double digits of their hometown. Now, why is that? Could that be because I spent 30 years there? Could it be because East Coasters talk a very specific way and the test is more designed for East Coasters? See, this opens up all kinds of questions, right? I don't know why I was the closest. I also don't know why this is so much more wide than my data value. And those are all great questions for a research class. Right now, we're just talking about the tool. Can we estimate, on average, the distance between the geographic midpoint and your hometown? And the answer is yes, and it's between 390 miles and 724 miles. Okay, I told you in class I was going to make this a quiz, but the more I realized it's so messy and there's so much to do, I decided to just make it a quick little, 15-minute playlist of 2 videos. Use it, please, if you want for the quizzes that are due on Friday. And definitely don't forget to turn that exam in, and we'll see you all on Tuesday.